Welcome to this demonstration for Maximo Visual Inspection. Today, we'll be going over how to use your phone and Maximo Visual Inspection mobile together to perform edge inspections. As a quick recap, the workflow for MVI is as follows. We first start by collecting data. This can be done on our phone, or we could already have all the images together in a folder on a local drive. We send this data to the mass server where the MVI instance is hosted on a data set, where we then label all the data. This provides important context for the model for when we actually do send the data back for training. Once the model has been trained, we can deploy it out to our edge devices so that we can actually conduct the inspections. Our use case today is pretty simple. We want to differentiate between good and bad breadboards, where good breadboards have at least one resistor on them and bad ones don't. Okay, let's get started. As you can see here, we have two breadboards. The one on top has a resistor along with a few other components, and the one on the bottom just has LEDs. According to the criteria for our demo, the one on top should pass, the one on bottom should fail, and the overall inspection should fail since there's a component on the screen that does not pass. To sort of set the stage, let's assume we're on an assembly line or a production line, and we're working with these electrical components. We need to ensure that they're wired correctly, and we need to perform this validation both quickly and be accurate about it. I'll show you now how MVI Mobile makes this process very painless. You just go in and take a picture, and the rest of the work is handled for you. So you can see here, the breadboard on the bottom has failed. There's no resistors on it. The breadboard on top has actually passed. There's no indicator on the list, and the overall inspection has failed. Now I'll show you how I set this up. First, we have to create a regular inspection. This is Breadboard Inspection V1. After selecting a project, we select our model, which actually identifies all the various components of a breadboard. And you can see here how you can set the various thresholds, and you can come up with a variety of different use cases with just these thresholds. Next, we need to create our trigger model, or trigger inspection. This follows a similar process. It's in the same project. This model only detects breadboards, however, and we have added an additional rule to it, which is to conduct a secondary inspection whenever this one is triggered. And of course, once you select your inspection, the work is done. One last thing I wanted to do is cover data sets in a little more depth. So first, we can see the results of our actual inspection that we just conducted now in this inspection data set. And as we go into it, we see that only the breadboard model or breadboard detection model is actually activated. If we go into the actual data that is provided with this inspection though, we can see that the actual inspection failed, as it should have, considering that the bottom breadboard doesn't have a resistor on it. Now, if you wanted to actually go and train a model and you have all your data waiting for you, this is more or less what you would see, a bunch of images that you have taken, and when you actually go to label them, you see nothing on the screen. You would want to actually create a label when you first create your data set. So in our case, we would say come up with a breadboard or come up with a resistor object. However, we've already defined those here. To actually create the label though, you want to click on each object, or then click on the box tool or the polygon tool. And then you can see just how quick and easy this process actually is. And the reason why this is such an important thing is that it becomes easy for really anyone in the enterprise to sort of make use of this tool, whether it's to take photos for data sets, to label images, or to conduct the inspections themselves. Now we can move on to training our model. This is as simple as returning to our data set and clicking the Train Model button. Of course, we need to select what kind of model we want and change the name of it. Advanced users can change hyperparameters down here, and then we can train. And just like that, our model will be ready for us to use within 20 minutes. Let's recap what we have been over. In this presentation, we have been looking at breadboards as substitutes for electrical components, where a good breadboard has at least one resistor on it and a bad one does not. With this criteria, we were able to view a good and a failed inspection, as well as how you can pipeline inspections together to get more powerful and specific results. Online, we were able to see just how easy it is to label data and how seamless that interconnectivity between MVI and MVI Mobile is. With that, thank you very much for joining us.